Hello, mic check. This is Postdoc week number. Wait a minute. I believe it's 10 something. Let me check very quickly here. Week 107. So Postdoc Chronicles from week 107, and before we dive into the Postdoc, of course, like always, we're gonna feature a game that released August 28th, 2020, just last week. Jump Force Deluxe Edition on the Nintendo Switch. We're gonna talk about this, and also we're gonna compare it to an old game from the PS Vita, similar game. And this game is called. Let me wait until it loads right here. It's also a game based on the Jump Shonen Weekly series. Basically, Jump is the shonen serialized magazine that contains mangas on Japan. But on the PS Vita, we have something that's called J Stars Victory versus Plus. Okay, so similar game. It's basically a fighting game where your fighters are from all the manga universe or the shonen universe that we grew up with, like from like Ghost Fighter, Dragon Ball Z, Samurai X, Naruto, Bleach, and all those things. And basically, you get the characters and the villains, they get to fight in like an arena, and it's 3v3. And yeah, it's sometimes crazy because you can have like some dream fights, like for example, Kenshin versus Ichigo, and let's say Frieza versus Naruto, and all those things. And yeah, it's so much fun. And yeah, I played a lot of it. As you can see there, Shishio battling with some other peasants. But anyway, yeah, it's so much fun. And I believe that is Sasuke. Yeah, so you have Sasuke versus Shishio, and then you basically fight in this arena, and then it's just like a chaotic battle. And usually I don't believe there's like a competitive scene that revolves around this, because usually competitive scenes, they are usually like in a 2D plane, like one dimensional, because this one is very chaotic and a lot of things can happen, and then you can choose three people. So you just play this for fun. But yeah, just last week, a Switch version of this, it's entirely another game, but the very similar concept. Jump Force Deluxe Edition, released on the Nintendo Switch. Similar game. The thing is, the this game, when you play the cutscenes, for example, the frame rate drops like hell, man. Like the frame rate drop is everywhere. But then when you reach like the game, the fighting part, it's actually all right. Sometimes the resolution could dive very low. It's usually the technique used when they port 3D games to the Switch. The resolution usually takes a hit. The resolution is dynamic, so it changes every time. But basically, when you battle here, it's all right. And also, the campaign is very different, because here on the Vita, I remember, I played this a long time ago. I played this from time to time, but the campaign, I remember, you choose from like Naruto, and then Luffy from One Piece, and then Goku from Dragon Ball Z, and then each of them, like they go from like point A to point B and so on. And it's a linear story. And you have this world that combined and everything like that. And then there's like a higher evil, and I believe there was Toriko battling Goku there. But anyway, yeah, there's a campaign, but it's separated into three parts. Here, it looks like there's like an overarching campaign, and the new thing here is you get to create your own avatar. Like in the beginning, there's like an overarching story, like Frieza was attacking some stuff, and then Luffy, Naruto, and Goku was battling him. But yeah, you have an avatar that wakes up, and I believe you'll follow the story from the eye of the avatar, as opposed to the format here in the PS Vita, the J Stars Victory versus Plus, where you only follow the campaign through the point of view of Naruto, Luffy, and Goku. But yeah, it's a nice game. But yeah, sometimes it can get like, yeah, it's just chaotic. It's just like a chaotic, mindless fun. So if you just like have a few minutes and just want to invent a dream fight. So of course, the nice thing about Jump Force is it's basically updated. So I believe characters that are not yet here in the Vita. For example, My Hero Academia characters are here, for example. So you can play as them. But yeah, very very good Nintendo Switch game. So you should check them out, or if you have a Vita or a Switch. But anyway, very quickly, let's go to Postdoc Chronicles. So last week I mentioned that I was already able to solve the problem where I couldn't run requests on the grid. And so now I was already able to submit a bunch of jobs up to. I was looking at different slices of digest events, so that I can again validate default dire and Vinci shower modes. So I was submitting them, and then I have already one plot for the zero slice, and the plots look nice. They really coincide. Vinci is different but very minor, so I believe that's fine. But yeah, they look the same for the relevant parameters that I looked at. But this is for soft QCD. I was using MC generic from Revet. So the hard QCD, which starts at like slice 2, I'm gonna be using MC jets, and then again I'm gonna look at the if the plot differs between the three different Parton shower modes. And also I mentioned this also last week, but I haven't begun like doing this. Just last week is when I began doing it. Is Deepak assigned me this paper called Search for Maverick Top Hunters, and basically they look at a VLQ vector like quarks, heavier partners of the first three generation of quarks, like for example the up charm and the top, for example. So beyond that, there's like you can think of like a fourth like heavier top partner, and typically these models like this, it's called a VLQ vector like quarks. They look at a VLQ, and then usually the typical decay mode is the VLQs usually decays to either a Z, a W, or a Higgs. But then the problem is these kinds of final states or decays they've been probed in LHC, but we don't have evidence for the existence of VLQ, at least that decays in those particular modes. So this new paper just published like I believe early the first half of 2020. What they do is they propose VLQ, but instead of the usual decay chain, they establish a model where they could decay into things that we also cannot see in the LHC. And what are these other stuff that we can see? Well, these are also some other BSM particles. So for example, they in their model, the VLQ could decay into a dark photon or a dark Higgs, that breaks a new gauge or a new charge that they introduce. I believe they call it U1D. But basically, you introduce a charge to the standard model in addition to the standard models, and then the standard model is neutral or is not charged under this U1D. But then your dark photon and dark Higgs and all the other stuff, when you introduce that, is charged under that new U1D. Okay, so for example, your dark photons and stuff, and that's why it's called maverick. They call it a maverick. The term they use is maverick top partner, is because the decay chain is not the usual ZW or Higgs. And so what I'm gonna do is, because I believe in their paper they look at they look at the model, and then they look at like specific areas that could constrain their search, but they don't have like a search strategy or a specific constraints on the parameters. And so what I'm doing is I've been using this thing called the FeynRules, which of course I've also mentioned before. This is an interface, a package that you download, and then you interface with your Mathematica. And basically what it does is you write you encode the external parameters used, or the input parameters used by your model, your Lagrangians, and then all the other relations or the other equations that relate all the parameters within the Lagrangian that is a function of the external parameters. So you encode that, and then when you write it in Mathematica, what it does is FeynRules can compute for you, partial widths. It can compute the Feynman rules for those particular new terms in the Lagrangian. And what you can do with it is, the best thing that it can do is it can output this thing called the UFO file, universal FeynRules output. And these UFO files are typically structured or designed such that existing Monte Carlo generators, for example, a MadGraph, can use these UFO files. And then now what you can do is you can now simulate your events on Monte Carlo generator. So from a Lagrangian up to some simulation of events, like it's like you're simulating, you're colliding proton, and then if your Lagrangian is correct, or if our universe is really described by for example, in this case, the Maverick top partner model, then we should see those particular like behavior or the distributions that is coming out from that model at the LHC. So that's what I'm looking at. But currently, it's hard because the Lagrangians are really, really complicated. So there's a lot, like you have a Lagrangian for the scalar sector, for the fermion sector, and so on. So I'm still encoding it. I haven't tried it if it works, because I'm also doing it in my Qt. And the problem with my laptop right now is also it's also simulating events for our MUED project. So I'm still, every time it's done simulating, I'm still running some other combination of parameters. So the space that I'm still scanning is still large. So I think it will still take months or more before I can finish all the scan, and then we can have a paper for MUED. But yeah, my laptop has been scanning these parameters for a long time now, and until now it's still scanning, and it's a bit slow because it's MadGraph with matching. So it's running, and then sometimes my laptop kind of slows down. But yeah, but I'll try after I've done incorporating the things in FeynRules. Hopefully this week I can try an attempt to output some UFO files from it. But yeah, anyway, that's my report for Postdoc Chronicles week number 107. I'll see you next time. Thanks for watching, and bye bye.